All right, you found Algebra 2, Lesson 3.1, Solving Systems of Equations Graphically. So hopefully you're in the right place, and hopefully you've got your notes with you. And let's go ahead and look at this foundational issue or a lesson for Chapter 3. So foundational lesson for Chapter 3, Solving Systems Graphically. All right, so what is a systems of equations? What is it? It's simply this. A system means that there's more than one. It's two or more equations where the solution, and don't miss that, where the solution is the, do you remember? It's the point of intersection. The solution is the point of intersection. All right, so if you look on the graph here, we've got two equations here, and we're going to graph them. The black one is already graphed, and it's right there for you. We'll go ahead and graph the blue one. As you know, y-intercept first, so let's go to 4. Put in the y-intercept, looking at the slope. -1 over 1 is down 1 to the right 1, right? So we'll go down from that point 1 to the right 1, put our second point, and now we're ready to draw our line. Now, what happens with some students is when I ask them to solve a system by graphing, this is all they give me. They do this, and that's it. And the last thing you have to do is you've got to indicate the solution. And remember, that solution is this point of intersection. And so what you need to do is give the coordinates. In this case, the x is a 2, right? And the y coordinate is also a 2. So this is the point 2, 2. The point 2, 2. All right, so what is the solution to the system of equations? It's the point of intersection. Now, I want you to look at A, and this is an important concept to understand. The point of intersection is the x value and y value that solves both equations. That solves both equations. All right, so focus your attention here on the graph again. I want you to understand that every point along the black line, this point, the x and y coordinates of that point will solve the black equation. They will not solve the blue. That point, the x and y coordinates will solve the black equation, will not solve the blue. This will solve the black, will not solve the blue. This point will solve the black, will not solve the blue. This point will solve the black, will not solve the blue. This point will solve the black, will not solve the blue. However, this point right here solves both the blue and the black. Okay? Now, you got points out here, right? That point's not solving either one. Right? Any point along the black line solves the black equation. Any point along the blue line solves the blue equation. And the point of intersection solves both. So what if they gave you a point? So let's look here at my 2, 2. What if there was no graph, they gave you the point 2, 2, and they said, does it solve the system? Well, what would you do? Well, it's pretty simple. You'd put in the x to the 2 for the x, the 2 for the y, and see if you get a true statement. 2 equals 2. Oh, we do. It worked in the black one. We'd put the 2 in for the x, the 2 in for the y, and see if we get a true statement. And you know what? 2 equals 2, and we get it there as well. And so, yes, indeed, that point solves both. So that's the idea there. All right? That's what we're looking at, and that's the concept. That's the idea. Okay? So remember, the point of intersection is the x value and the y value that solves both equations. All right, something to memorize. Here's what's going to happen down the road. 3 months from now, 9 months from now at the final exam, a year and a half from now on the ACT, the American College Test, or 2 years from now on the SAT, Scholastic Aptitude Test, you are given a system of equations. And you will have to, at that point, have to think, how do I solve this? How do I solve these? And this is what should come to mind. You should, in your brain, think of the 4 ways to solve a system of equations. All right, first off, graphing. That's what we're going to do today. Graphing. So you can solve systems of equations by graphing. The second method, maybe you remember them from Algebra 1, is substitution. Substitution. substitution, substitution. Where's my toot? I don't know. Substitution, substitution. Looks so funny. All right, whatever. Third way is the elimination method. Elimination. Some also call it the addition method. The elimination method. Elimination. That one is spelled correctly. And the fourth way is matrices. 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 We have a whole chapter in this year's course that will deal with matrices, and I believe it's chapter 5, maybe chapter 4, maybe next chapter. All right, so there are four ways of solving a system of equations. And this should be the thought in your brain when you come across a system. Do I want to solve it by graphing, substitution, elimination, or matrices? All right, and then you can continue on from there. All right, so let's talk about linear systems. Linear systems, remember, linear is nothing more than a system of lines. Linear systems have three possible types of solutions. Three possible types of solutions. All right, you can see on the right here with my graph, the first one is illustrated, and this is simply a single point of intersection. A single point of intersection. So what is that solution? I'm going to do SOL, and let's look at the coordinates, and -2, 1 are the coordinates of that point of intersection, right? So a single point of intersection. Do you guys remember what these are called? They're called consistent and, do you remember the second word? The second word is independent. Independent. Consistent and independent. All right, the word consistent means there is a solution. Independent means it's a single point solution. Consistent and independent. For this to happen, the lines must have different slopes. And that's obvious. The blue line has a negative slope. The black line has a positive slope, therefore definitely have different slopes, right? So that's a normal linear system. You got a point of intersection. What type of solution is it? Consistent and independent. Second possibility. Second possibility. Second possibility are infinite points along the line. Infinite points along the line. All right, we do have a solution. All right, and before I go too far, before I fill in the red, let's say what the solution is on this. The solution is the equation of the line. So how would you say the solution? Well, it's the equation of the line. All right, so I got a y-intercept of -2, right? I'm trying to write the equation of the line. Remember, you need y equals mx plus b. All right, what's our b? -2. Now we got to figure out the m. Okay, if I go up 2 and to the right 2, so, or up 1 and the right 1, so it's a 1 slope. So that's actually the equation of the line, y equals x minus 2. That would be the solution, right? The equation of the line. Because remember, it's every point along the line, and one line's on top of the other. So there is a solution, so we say consistent. There is a solution, so we can say consistent, but it's not independent. There's not a single point solution. There's a multiple point solution, so it's dependent. Dependent. Consistent and dependent. All right, and that leaves the third situation here. Let me go a little higher. All right, so the third, oh, and let's finish that last thing underneath 2 there, right here, right? So on that last thing, again, they are the same line. So obviously they would have the what kind of slope? Same slope, right? But beyond that, it has to be exactly the same. So not only the same slope, same y-intercept, right? For it to be consistent and dependent. You got to have the same slope and the same y-intercept. They're the same line. All right, third scenario, no solution. No solution. So what would you call the solution in this? It's the null set, right? There is no solution. And look at our example here. You know, where do those intersect? And the answer is nowhere, right? You take a look at those two lines, and where is the point of intersection? The answer is nowhere, and they never will by definition of parallel lines. So consistent is when there is a solution. So if there's no solution, what are we going to say? Inconsistent. Inconsistent. That's the type of solution. What is the solution? Null set. What's the type of solution? Inconsistent. And again, the lines are parallel. So in this case, same slope, different y-intercept, right? They have the same slope, they have a different y-intercept. All right, so three possibilities. You got a point of intersection. You got a point of intersection, right here. And that point of intersection is the solution. It's consistent and independent. You have the same line, like there. In that situation, it's every point along the line. So the solution is the equation of the line, and it's consistent and dependent. Third scenario, like this one, is parallel lines. It's inconsistent. There is no solution. The answer is the null set. Okay, let's continue on. All right, so D. To determine if a point is a solution in the system, and I showed you this earlier on the introduction, to determine if a point is a solution to the system, just sub in the value. You can write out substitute if you want, but sub in the value of x and y to see if it solves. And again, here's the key, both equations, right? You got to solve both. As I showed you earlier, you got to point along one, may solve the one, but it's got to solve the other. That's the point of intersection. So here's a situation. We're asked, is the point 3, 1? Is the point 3, 1 a solution to this system right here? So this is what you need to do. You need to lay out both equations and see if it solves both, because it may solve one and not the other. All right, the x is a 3 and the y is a 1, right? Just subbing in here. And we get 2 equals 2, and that's a yes. Okay. So it does solve the blue one. We know that 3, 1 is a point along the blue line. But is it a point along the black line? Well, here, again, we got to do the same thing. We got to sub in. And we got to find out. 3 times 3 is 9, and 1 is 10. Okay, in this case, that's also a yes. So is it a solution? Yes, it is, because it's yes to both. All right. Sometimes it'll work on the first, won't work in the second. You say, no, it's not the solution. It's got to work in both. It's got to work in both. It's got to work in both. Okay, next thing is something we should know how to do. We just have to remember that we're doing a system, and therefore, because it's a system, we have to give the point of intersection. So graph each function to determine the point of intersection. I'm going to use the intersection symbol. You can write out the word intersection if you want. Hey, don't neglect how we graph lines. We've already reviewed it today. Y equals mx plus b. And so just a quick refresher. Remember, plot the y-intercept first, the b value, right? From the y-intercept, use the slope to plot the second point. And remember, the slope is the vertical change in y, the up and down, divided by the horizontal, the left and right. All right. And then simply draw a line through the 2 points. That's how you graph the lines. But remember, when you're all done, determine the coordinates of the point of intersection. That's your solution, the coordinates of the point of intersection, because remember, you're going to have an x value, you're going to have a y value. So the coordinates of the point of intersection is what you're after. Okay, let's take a look at an example here. So we're asked to solve by graphing, and we've got y equals 2x plus 4 and 3x plus 3y equals 3. Okay. The first one is all set and ready to go. If you want to do it yourself, go ahead and pause the video and see if you got it correct. If you want to just watch and continue on, then just keep going. All right, going to do the y-intercept first, right? Y-intercept of 4. Looking at my slope, which is a 2 over 1. So I got to go up 2 to the right 1, draw my second point. Now, I will tell you this. You need to be careful and you need to be accurate. So I want to be accurate on this. So I'm going to go look right here at my y-intercept. A 2 over 1 mathematically is the same as a negative 2 over negative 1. So what I want to do is I want to go down from my point of intersection 2 and to the left 1. That'll give me another point. And I'm going to do it again. Down 2 and to the left 1. Going to do it again. Down 2 and to the left 1. See how I'm lined up? Because look, we're after a point of intersection. And one of the negatives of graphing to find the solution is you got to be accurate. And the solution isn't always a point with whole number coordinates or integer coordinates. All right, so that's the blue one. Black one, let's move the 3x to the other side. Let's divide both sides by 3, right? And now we're ready to graph it, right? We've put it into y equals mx plus b form. We are now ready to graph. Again, y-intercept is first, so we got to go to 1. Let's use our slope, down 1 and to the right 1, right? You got a negative 1 over 1 slope. We're going down 1 to the right 1. And you know what? This is the same as a 1 over negative 1. I'm going to go up 1 and to the left 1. And look at, there we are, right at our point of intersection. Not a pretty line there, but that's what happens when you do it graphically. And don't neglect to finish off your solution as that point of intersection with coordinates what? Negative 1, 2. And that's the solution to this system of equations. All right? Couple more examples. So here's another one. Again, if you want to pause the video, go ahead and try it on your own. If not, I'm just going to roll on. Okay, so let's add a negative x to both sides. Let's divide both sides by negative 1. That's going to change the sign of everything, right? So we have y equals x minus 4. Plot the y-intercept first. Up 1 to the right 1. See, I'm going to keep going up 1 to the right 1. 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 Because I don't know where that point of intersection is, and I want to be accurate. Okay, so there we are for the blue one. Black one, add a negative 2x to both sides. Divide both sides by 3, so we get negative 2/3 x plus 1. Okay, point of intersection, or the y-intercept is 1, 0, 1. From there, go down 2 and to the right 3. Okay, that's all I need. I've hit the line already. I found my point of intersection. Remember, you gotta say what the solution is. And it's the point 3, negative 1. X coordinate of 3, y coordinate of 1. Again, you can put 3, negative 1 into the blue equation. It will give you a true answer. It'll be true when you're done. You can put it in the black, and it'll be true when you're done. And that is the point that solves both of the lines. All right, one last one. All right, so here's a unique one for F. Let's do the black line first. That's traditional. All right, so we're going to move the 3x to the other side. So you got a negative 3x plus 1. We're going to divide both sides by 3. Y equals negative 3/5 x plus 1/5. Now, for some reason, students go bonkers over this 1/5. I don't know why. Right? 1/5. It's a fifth of the way between 0 and 1. Just go on your y-axis and go what looks to be about a fifth of the way, right? Probably right about there. I mean, that's it. Now the slope here, I'm going to use my green for the slope. I need to go down 3. So let me show you that, right? Remember, I'm at a fifth. So that's 1. That's 2. And that's 3 right there, right? And then I'm going to the right 5. So remember, I'm still at a fifth, so my second point is about there. right? That makes sense? All right, and we're drawing our line through that. Again, if I were doing this for homework, I'd have a ruler, some kind of straight edge, um, and I'd be drawing that. Now, how do you graph y equals -2? Remember, every y coordinate equals -2. So that's a y coordinate of -2. That's a y coordinate of -2. That's a y coordinate of -2. Y coordinate of -2. Y coordinate of -2. Oh, look, right there. Y coordinate of -2. There is the line of y equals -2. Now, it appears to me that the point of intersection is the point for -2. That's how it appears. But you know what? We had a fifth right there, right? And how accurate was I? I don't know. I really don't know. So if I were with a ruler and at home, it may look maybe like 3.9 -2. Now I know the y coordinate's -2 because that blue line is on -2. I'm not really sure about the x coordinate. See, this is one of the things of why graphing isn't the most valuable way to solve a system. Because there are many situations where you won't necessarily know the exact value of the x or the y coordinate. All right, so guess. The way mine looked, it looked for -2. To be honest with you, when I did my notes, it looked more like maybe 3.9 -2. In that case, I would give you a little bit of leeway either way. But look, if you say 4.5, that's too far off. 3.1, you're too far off. All right. But I would give you leeway. All right, that's the lesson. Remember, don't worry about the homework. You'll come into class tomorrow and work it in class as we flip the classroom. And hopefully you didn't flip out over this lesson. So let me go back and do a quick review here and we'll be done. All right, so remember, you're looking to solve systems. What is it? Two or more equations where the solution is the point of intersection. So remember, point of intersection, that is the key. 4 ways to solve. So that's something you should memorize. Graphing, substitution, elimination, and matrices. 3 possible types of solutions. Single point of intersection, consistent and independent, right? Consistent and independent. If they are the same line, then it is consistent and dependent. And if the lines are parallel, then there is no solution. It is inconsistent. All right, from there, what if they ask you to verify if a point is a solution? You got to put it into both, right? Put it in the first, see if it solves. Put it into the second, see if it solves. It's got to solve both. All right, and then how do you graph? And that's what we ended up doing in the last part of the lesson. Graph the 2 lines. Remember, make sure you indicate the coordinates of the point of intersection. I didn't know I could move that around. Make sure that you say what the solution is with the point of intersection. All right, that's the lesson. See you tomorrow in class.